So let's do an example of a tangent. So same routine, A is the coefficient in front, but we know that A doesn't affect the amplitude. It doesn't have an amplitude, but it affects the stretch. B, still that number right there. But remember for tan and cotan, let's write it again because it's a big deal. The period is pi over B. So that makes my period here pi over 3. Phase shift is still the zero, the x part. So my phase shift is still x over 3. And once again, I'm still going to say, well, I'm going to put that right in the center because that's my new center. So I'm going to put them right in there before I forget anything else. My displacement, you could say up 1, you could say just positive 1, and the center line becomes y equals 1. So the center line is y equals 1. Okay, the equation of the asymptotes, remember we said it's going to be, for the asymptotes, it's going to be x equals, take any asymptote, plus, and in this case, it's just n times the period, where n is an integer. Okay. The range, look, we know for tan and cotan, the range is always going to be all real numbers because they just curve up and down. All right, so here we go. We got all our basic information. So the period's pi over 3. So if I start at pi over 3 and I go pi over 3 spaces to the right, that takes me to 2 pi over 3. If I'm at pi over 3, I go pi over 3 to the left, that takes me to 0. And we start chopping all this in half. So that would be pi over 6. Okay, this is going to be really annoying. This one's actually easier to do if you do it in terms of twelfths. See, the period's pi over 3. So the period is pi over 3. We know we're chopping it into fourths, so that would be pi over 12. So every one of these increments should be pi over 12. So 0, 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12. So we got our horizontal axis labeled, which, as I've said thousands of times, we know is the most annoying part. Then here's where it's crazy. Somebody says, all right, I either have to remember the pattern of when tangent on our tangent graph, because I'm one period to the right of center, one period to the left. If I remember the pattern that tangent should have asymptotes at these middle values, then that should really help me. You say, okay, I don't believe that. Okay, well, let's test one. I think there should be an asymptote at pi over 2. So if I plug pi over 2 in there, pi over 2 minus pi over 3 is pi over 6. 3 times pi over 6 is pi over 2. Tangent of pi over 2 does not exist. So I convinced myself that there's an asymptote there at pi over 2 because it doesn't exist. And then I say, oh yeah, so now I'm convinced that for tangent, that's when the asymptotes are at those halfway points. Then you say, all right, my center line was at 1. The A value is 2, so that means I'm going up 2 spaces, so that would be a 3. Going down 2 spaces, so that'd be a -1. And then for tangent's always going to have a point right there in the center. And then tangent's going to go up to the positive tangent is going to go up to the right. Negative tangent would go down to the right. So I have that point right there that showed me that stretch. So it's stretched out to there. And then the curve just fits inside the asymptotes. Then the annoying part. I know I'm going to have points there and there. So this guy needs to match up. And then over here. But the whole point is it's symmetric. Because what happens every year when we do this is somebody will draw a curve down here so that these two curves are running side by side. That doesn't happen. Or draw a curve up here so that you have two curves side by side. That never happens. You always have this repeated pattern so that there's symmetry, so that you're down on the left, up on the right. Okay, equation of the asymptotes. X equals, so just pick an asymptote like pi over 6. Pi over 6 plus n integer times the period pi over 3. Okay. The end. You just did a tangent curve. So that wasn't so bad, was it? Because I got a cotangent curve to do next. I guess we can do it on. Okay, cotangent. So I made this one a little bit goofier. So A is 4, B is 1/4. Well, wait a second. That means the period is pi over 1/4, which is equal to 4 pi. Oh, so this one's going to be a little weird. This one's going to be just a little weird. The phase shift is negative pi over 2. So I immediately go over here and do negative pi over 2 as my new center. So that phase shift eats the new center. I'll whoop that in there. The displacement, you could say down 3, or you could just say negative 3. So the center line is now negative 3. We'll get to this, and we know the range is going to be negative infinity to infinity. So once again, here we are. Got to label these points. So if that's negative pi over 2, and I got to go 4 pi, negative pi over 2 plus 4 pi. So that'd be 8 pi over 2. So that's 7 pi over 4, 7 pi over 2. Negative pi over 2 minus 2 pi. So that'd be negative 9 pi over 4. So this one actually ends up over 2. This one actually ends up being pretty easy to chop up because that'd be negative 10 over 2. So negative 5. This one would be negative 6 over 2. So, I mean, positive 6 over 2. So 3. So it looks like the pattern here is every 2 pi. Okay. Now we can sketch ourselves a nice graph. Somebody says, oh, but I got to, oh, and let me see, A was 4. So that's going to go up to 1 and down to negative 7. Yeah, negative 7. If it was a negative 3 and it went down 4 spaces. All right, then somebody says, oh, I don't remember the pattern. Where does cotan have asymptotes? So if you don't remember that cotan is the center and the end, do a test. Like, oh, I'm going to plug pi over 2 and negative pi over 2 in there. So that makes 0. 1/4 times 0, 0. Cotan of 0, does not exist. Cotan of 0 does not exist. Thus, that becomes my asymptote. And hopefully then we remember that, oh yeah, therefore for cotan, those asymptotes are on the ends and the center. And then we can say, all right, so we know we're going to have those center points right there. Cotan is opposite, positive cotan is opposite of tan. So up on the left, down on the right, up on the left, down on the right. Okay. It would look like that. And then you'd say, okay, here we go, the asymptotes. So pick any asymptote. Well, how about that negative pi over 2 right there in the center? Plus n times the period. N times 4 pi, the end. Because I've just got an asymptote every 4 pi spaces. All right, so there's a tan and cotan example.